Mechanisms can be really hard, but not this one. Nucleophilic substitution. What is a nucleophile? It's a lone pair donor. It's a species of 2, 3, or 4 atoms that have a lone pair, 2 delocalized electrons. The 3 nucleophiles that we've got to learn for A levels are hydroxide, cyanide, and ammonia. And like you can see, we have 2 dots which represent the 2 electrons that need to be paired. Now, we're going to start off with the OH, the hydroxide. The conditions are warm aqueous sodium hydroxide. Do not say hot ethanolic sodium hydroxide because that comes in a different mechanism, elimination. That's not it for now. Warm aqueous is what we need. Now, in our mechanism, we're not going to include the sodium because it is called a spectator ion. It doesn't do anything. It's not involved in this mechanism at all. This is all we care about, the OH. We're going to be drawing arrows here. Arrows represent the movement of electrons, the transfer of electrons. So ideally, these electrons are going to be transferred to the carbon. Why do we do this? Well, we're going to do this to make the compound either stronger or more useful. And the ones that will be attacked, this thing, nucleophilic substitution, is only about chloroalkanes or bromoalkanes, any haloalkanes, because they're quite vulnerable, they're quite weak, and the compound just wants to be more and more strong. First things first, there's going to be a delta plus and a delta minus. That already is one of your marks. There's a covalent bond between the carbon and the chlorine, but the chlorine has got this ability. It is more electronegative. It's got the power to pull the electrons towards itself. The carbon's not happy. Hey, come on. This was a covalent bond. We're sharing electrons. Why do you take them for yourself? And so the carbon wants to kick out the chlorine, and fortunately, there's a nucleophile just around the corner, and the carbon would want to have it in the team to make a stronger compound. In this case, we're going to get an alcohol. We could get a nitrile here or an amine here. We'll get onto those in just a bit. First things first, you're going to draw your arrow towards the carbon. The OH will attack the carbon, and then the carbon will kick out the chlorine. Now, your arrow must start from in between those 2 electrons, those 2 dots. It's got to be starting from in between the 2 dots because we're showing the transfer of electrons. Can't start from anywhere else. And make sure that you clearly point out the carbon. Don't make it ambiguous. Now, the carbon will kick out the chlorine and we will get an alcohol. We'll get an alcohol. Be very careful here because the carbon has a bond with the oxygen from the hydroxide. It doesn't have a bond with the hydrogen. That is ethanol. We went from chloroethane to ethanol. We're still going to get a byproduct. We will get a chloride ion. Not a chlorine, a chloride. It's got a minus charge and it's got 2 dots, 2 unpaired electrons. Where did these come from? Well, remember here, the chlorine wanted to take them for itself. The carbon said, okay, take them. I don't mind. I've got OH coming my way. So you take those electrons, and the chlorine did take the electrons. Now, we did say that the sodium was a spectator ion, and now what will happen is the sodium has just lost the OH. You know, this OH was once bonded to the sodium. Now the sodium's on its own, and these 2 will basically join together. You don't really need to show it, but we will get NaCl later on. Again, you don't need to show it. That is the entire mechanism. The exact same thing goes for the cyanide, except we're going to have the cyanide. Now, we need hot ethanolic potassium cyanide. Hot ethanolic potassium cyanide. Again, potassium here, it's a spectator ion. It's not going to be involved in any sort of way. And the exact same thing happens now. Between the carbon and nitrogen, there's a triple bond. You don't really have to show it. You can just write this. That would be more than enough. Your negative charge in any of these nucleophiles, it is optional. You don't have to put it, but you must put those 2 dots there. Again, the carbon's going to attack this carbon here. This carbon will kick out the chlorine. We're not getting an alcohol this time. Might have figured it out. We will get a nitrile, so a compound that has a CN functional group. This one in particular is called propane nitrile. Yeah, but Hamza, hold on a second. We were dealing with chloroethane. How did we go into a propane? Well, because we've actually got 3 carbons in a row now. The length of this carbon chain has increased by 1. So we've gone from an ethane to a propane. Yeah, but Hamza, that's the functional group. Do we still consider that carbon? We do. So that is propane nitrile. Final thing is ammonia. We need excess ammonia, high temperature, high pressure. Why do we need excess ammonia? We'll get onto this in just a bit. So everything goes as usual. You put your delta plus, delta minus. Carbon's not happy, so he's more than happy actually to bring in the NH3 in the team. And again, substitution is all about swapping one functional group for another to make the compound more strong or more useful. We're going to get our second arrow here. Now, you might have figured it out. The nitrogen can actually only take 3 bonds. At the moment, it's got 4. It already had 3, but it's taken another one with this carbon, and now it has 4. So it will have a positive charge. It's got too many protons. It somehow needs to kick one of them out. The carbon says, hey, you've joined the team. We're more than happy to. But now you're making all of us unstable because of your positive charge. So you need to get rid of someone. This is where the excess ammonia comes in. I know excess means probably thousands, but it's just one. Only 2 ammonia are going to be involved in one cycle. So this ammonia goes, hey, I can take one of your hydrogens, and I myself, I'm going to turn into NH4+. So you get a third arrow and a fourth. And then at last what we're getting is an amine with NH2. Again, that third hydrogen has been taken, and our byproduct is NH4+. And do not forget about the chloride that we kicked out at the start. Now, eventually what will happen is we've got an anion, we've got a cation. These two will actually join to form NH4Cl. But again, you don't need to show this. You can just write your byproducts separately, and that is it for your nucleophilic substitution.